Hello, third hour. Mr. Samuelus. How, are you supposed to say hi, Mr. Samuel? Okay, so enter. Who's the first group going? Boom shakalaka. Student group number 5. Get ready to answer questions. Stretch out. Don't pull any math muscles. All right, here we go. All right, so hey, it's 2018. This is rare. Mr. Samuels has found his courage to try to make a movie with this computer. I won't complain any further. Don't write anything down yet. Remember how I told you back in the beginning, my notes were a way that you could actually read them, and I cut components out of the book that pertain to what would put your mind in the right spot for understanding. And then always what I do is just talk about what I have here. What I have here from the book is actually going to be in this green box coming up here. But just as a reminder, if you're asking yourself, why do I have to find a focus and a directress? This is so stupid, right? And I mentioned that in space, maybe movement of something's parabolic in nature. And the way I think about it, I could be completely wrong, but I'm going to go over this like I did second hour. I watch my space movies. Sometimes you're unaware what class is this actually, by the things that I talk about. But Voyager 1, Voyager 2. Watched a great show. It's either How the Universe Works or Space's Deepest Secrets. I forget which one it was, but they talked about the 1970s, how to figure out how to get these probes to go all the way and scan our solar system and get real cool pictures of our planets. What it was they found out the math. A mathematician actually solved the problem, not a space person working for NASA. It was a mathematician that found out how to slingshot these probes, Voyager 1 and Voyager 2, around the planets. And through slingshotting through Jupiter's gravity, which is enormous, they actually snapshotted pictures of Jupiter and a couple of its moons. And then it allowed it to get to Neptune and Uranus. Right? That's what they always do in class when I say that name. Much faster. All right? And now that's a way that they do, all kind of motions, slingshotting through gravity. So anyway, why do I bring that up? Because when you slingshot around a planet, that's like a parabolic shot because you loop around it and then you shoot off into a direction, a different direction. So imagine that little focus point right there that I'm showing there is maybe Jupiter, right? And then a thing slingshots around it, shoots off into a direction into another planet. So anyway, so like I said, this little sentence right here is dictated by this. Now remember, okay, how come I know an x squared equals 4py goes up and down? Because for every y, say it, there's two x's, and you can actually, in 2 seconds, graph a y and then put two x's. I'm showing my fingers right here in class that you don't get to see, but for every y, I'll write it here. For every y, here's a y coordinate. There's two x's. The only way that could happen is if I have a parabola doing that or that. So it has to be up or down. It's a new concept. I thought about this over the weekend to help you guys. And then for every x, there's what? Two y's. The only way that could happen is if you have a parabola going this way or that way. Because when we do hyperbolas, then ellipses get jacked up, the things you have to remember. And then it also jacks up the students' minds on parabolas. And I'll reference that when we do that. So I'm just talking about common errors that students make. All right, now, here's what the sentence said up there. Boom. Hey, doesn't that look familiar, what I just revealed there? What does that look like? X minus h squared. Where did you see that? With circles and ellipses, as far as, what goes with x and what goes with y. H goes with x. K goes with y. But a parabola, I'll blabber as you write this down. That's what the students are actually doing, the note takers. It's not a center, it's a vertex. That's the key point. So h comma k is the vertex. Same idea. And I made a management decision to compare today to yesterday. Yep. That's what it is. So take a moment to write that down. I don't think I have much more to say about that because of what we did with ellipses and circles. We should know. Here's a common error. Um, Look at the second one. Common error when I pull a student. Who got picked? 1, 2, 3, 4, 5. All right, you guys are up first. I'm going to ask what's the vertex. Common error. What goes with y? The what coordinate of the vertex? Y. So it's actually h comma k. And I should write this down. Common error. People when they look at this, they just go in order. No, it's h comma k. When we have numbers in there, I often have people put K, comma H because they just go left to right. Don't do that. All right, and then I'm going to space this out a little bit, and if you need me to go back to this, I don't want you to memorize that stuff in the middle. I'm not even revealing it because that's what serial bowl table will do for us, right? Serial bowl table will tell us where the focus and the directrix is. And the axis of symmetry is just the line that cuts it in half. I probably should reference that in the movie. Okay. Hit a pause. Oy, caramba. That's not right. That's a faux pas. There we go. All right, we're back. Okay. So here we go. It doesn't say to graph, but you're a silly fool if you don't. Anyone? Graph. You're a fool. A fool. You call students fools? Oh, I call them worse. All right. Jamokes, right? Because how can you play serial bowl table if you don't graph? Now you ready? I got group number 5 got picked. You, because I said I can't say their names online. She's shocked. Careful. What's the vertex? Careful. Oh. Nope, you don't distribute. This is all actually in order. Remember, this is in this format. Shh. Was that you? Wait. I thought I pointed at you. Okay, you thought I pointed at you? Okay. The second thing that you said was right. It is. Oh, what is that letter? H? I'm getting confused. All right, 3, negative, comma 2. That's what I mean. People that just go in order and just do 2, negative 3. You're not even thinking. Okay, so she answered. Now it's you. Okay, no, you. Don't back away from that pointing. All right, what is P? Well, that's in that position and that's in that position. What does that make P? P equals 1. And yeah, last hour I had a struggle with that. And I think we're missing, the formulaic thing about 4P. And where did that come from? It just is when we put it in this format. So if 4P is in this position, 4 is in that one, that makes P have to equal 1. All right? P is the, what did I say yesterday? No, P is the, it rhymes. Come on, you guys, my little, P is the what? P is the key. My math teacher, junior year. That was his saying. Okay, boom, boom. You're a silly fool if you don't graph this. Because how can you play serial bowl table without at least a representation of this? Okay, oh shoot. All right. Why is it right left? Because for every x, everyone, there's 2 y's. That makes it right or left. Why is it right, everybody? Because the number 4 is positive. Right is a positive direction. With that being said, last student in that group. Hey, oh, don't look at death from that student. Holy cow. All right. Which way does this go then? To the, I just said it. Oh, I got to pause. I don't know what's going on here. Maybe. Do you know the percentage of people that are actually, when they're absent, are actually going to my dang calendar and keeping up? The percentage is like 5%. What should it be? 100%. It's December. I have a calendar that you don't even have to go to Haiku. You just have to one click and see what I did and watch a video. This one. And 5% of the people do it and expect the world to stop until they catch up. This is not reality. You got to do what you got to do to keep up. Okay, here we go. I'm calmed down now. Why don't you go? You go right 1. So P is 1. So it's very easy. P is the key. Serial bolt table means I go right one, and then I'm not even going to ask you what that coordinate. Oh, by the way, the vertex is. Oh, I already have that. I don't know why I have it right. Or twice, I mean. So the focus is now simply -2, comma 2. And then, sorry to hit you here, student, but which way do I have to go for the directrix? Back one. So, okay, now this is where this gets... I'm erasing that because I want a better picture for that parabola. What's the directrix equation? Is it x or y? Nice. And x equals what when you go backwards one? -4. Right. It's so simple. Now, the reason I erased my not so nice parabola, I'm going to do the focal width. What's the focal width, everybody, from doing your homework yesterday? No, what's the total focal width? 4. What does that mean I do for the focus to come up with some other coordinates? What do I do at the focus? I have a student in the back going up, down. You go how far up and how far down, though? Not 4 up and 4 down. No, 2 up and 2 down. Because this focal width is a distance of 4. What that does is get these other coordinates, and then watch what I do here. This is graphing 101. This is another, I know you don't have the time to do this normally in a test, but just talking out loud here, which is how most people talk out loud. -2 comma 0. X is -2. Let's go up to this equation. Plug in -2, and I'll write this, online. What's -2 plus 3, everybody? I don't know why that negative disappeared. What's 1 times 4? What is 0 minus 2? What's -2 squared? That's equations. See, that's why that point is on the graph, because it solves the equation, meaning it makes a true statement. Okay, so I just thought I'd share that after we do the focal width and this weird thing. So that's proof that those coordinates do exist. Okay, sorry for my outburst, but it was needed, and I'm going to play this in all my other classes because I swear to dog, I am sick and tired of how many students do not look at the calendar when they're absent, when it's there and it's so easy. You have everything. I had nothing. Back in the day, I didn't have a pen. I had to stick my finger and write in blood because we were not allowed to have pens or pencils in school. And you guys get it all, everything. I also had to walk uphill to school and then uphill back in the snow, no buses, nothing. All right, what's next? 6. All right. Here we go. Go ahead and write that question down. What's the vertex? Group number 6. Student, first one I picked. And this one is nice to go in order because it is X, Y. Which way does this go? Oh, crap. All right, it goes downward Y. I had someone verbalize it last hour, and they said, well, Mr. Samuelis, it's because it's X squared, it goes up or down. And it's negative, so it's down. Because for every Y, there's 2 X's. So wherever this is, I just pick a Y, 2 X's. Like I said there, that has to be an up, down, or up or down. Not an up, down, or right. Yeah. All right. What's P, second student? What's P? We should be able to get this without having to do any math. This is pretty easy. Nice. That's why I just have this here. If you're, I don't get it. I don't know what to tell you. 4P equals this position. So P must equal -3. This is just something you have to memorize. I know it's strange. You just got to accept it. Okay, no, I didn't explain it or anything like that. But when we actually graph it and use the focal width, we found that a point actually landed there. Okay, next, students. Okay, so here, I didn't notice I had this graph. Oh, okay, I guess I did. Did I? Freaking out, man. I gave myself a coordinate plane this time. Nice. All right, 1, 2, 3, 4, -1, right? Okay, now, this goes down. So next, student, where should I go for the focus? Down. How far? Huh? 3. Good. 1, 2, 3. I'm not even going to ask you. And I'd be sad if you weren't able to get this answer, by the way. That focus is now located at -4, -4. Serial bolt table and basic math from grade school, coordinate plane, we're able to do that. And sorry, that last student, do it again. Which way would I go for the directrix? Because, So I went down 3 for the focus. Which way do I go for the directrix? Up 3. What kind of line is this? Red, dotted, straight. No, what kind of line is it? Ooh, your person helped you in your group. So just say that. Horizontal. So everybody, what's the equation, x or y? Based off of this student's in the last question, you should understand what it is. He said x when it was vertical, so it must be y when it's horizontal, right? Y equals what number? 2, everybody. Now, I held off on this. Everybody, what's the focal width? Ooh. Well, it's just really 12. You're supposed to take the absolute value of negative 12. But what does that mean from this focus? How far should I go right and left? There you go. 1, 2, 3, 4, 5, 6. I won't bore you. Too late. But I won't bore you about plugging in those points to prove that these points are in the, or make the equation true, let's say. Awfully wide. All right, and I'll hit pause for a second. So I was giving them time to finish that up, and now here we go. And I have a group. Group number 4. No passing. Okay, so you don't need to see them all. So I'll zoom in on the directions. Find an equation in standard form for the parabola that satisfies the given conditions. You'd be a silly, silly fool if you didn't what? Graph. Good. Okay, I'm not going to ask the student. If you don't know how to graph points, you're doomed. -4. -4. And I always do this probably for the help. I don't need a complete graph. I'm not saying find all the information. -2, -4. I always graph the focus as an x, just so it helps me pictorially. I always make the vertex a point because it's on the graph, and the focus is not, so I make it an x. Hey, first student in that group, which way does this go? Through serial table technology. It goes right. So this is all that's it. This is all you're showing. So then here's the next thing. What am I dealing with, second student? Is it an x squared or a y squared? So you are filling in this information. You're filling in y minus k squared equals 4p. That p got destroyed. P x minus h. I didn't want to leak into the other question. Now, well. Okay, I guess I could zoom in on this and then shrink this. Oh. Yeehaw. And then, okay, good. Okay, now, you should be able to answer this question. I'll ask the third, wait, okay, you do the beginning. Okay, so what does it start as? Y, go ahead. Plus what? 4, okay, I thought she said 1. Squared. Stop, I need the third student to do something. Oh, no, I don't think it's tough. What's P? Remember what P is? It's the key, by the way. P is the key. It's this. You P that way and you P that way. What? All right, to find the directrix and the focus. So what's P? 2. So what does that make this number right here? 8. And then what's the last part? You go ahead. So I don't know. X what? X plus 4. Oh, you just did something that is a common error. This is it. For parabolas, how many things are squared? Just 1. This is a common error, what she just said. I'm not picking on her. That does not become a parabola anymore when you have both x and y squared. Parabolas, only one of the two are squared. That is a common error, and I'm glad she actually said it now before it burns her later. What time is it? Okay, we're fine. Oh, I'm hungry. I can't wait for my lunch. You're a fool if you don't what? Tacos today. Okay. All right, so I'll start graphing this. I just realized I didn't pick somebody, though. Oh, gosh, get ready. What kind of line is y equals 1? Horizontal. And then 3, 4. 1, 2, 3, 1, 2, 3, 4. All right. First student going in reverse order. Same group got picked back to back. Hey. Okay, which way does this go? Up. Second student. Oh, no. Okay, I did this wrong, too. I went against what my thing is. I make that an X to denote that that's the focus. Where is the vertex compared to the directrix and focus always? Second student. So, what's this? Just you answer this, because I got to get some. What's this distance? How far is that? Total from the focus to the directrix. 3 spaces, counting. All right, don't get scared. All right, so then where should the vertex be? How far away from each one of these? Feel free to use a decimal, by the way. That's a hint. 1.5. Where is the vertex? Because this seems like, what is the vertex? It is 3, comma, and then I need to go half down, 1.5 down, or 1.5 up. Huh? So, well, go. What is? It doesn't matter. What is the coordinate?
It's 3 and 2.
Now this goes up, so it's x or y squared. Which one? X. X what? Come on, everybody. Minus. There's only one person. This is killing me. Equals. Stop. What's p? Come on, somebody tell me what it is. No, what's p? How far is that distance? No, it's not 3. It's 1.5. You guys are killing me. It's 1.5 up and 1.5 down. So what is 4 times 1.5? 6. This is not the things that should be CAT students should be struggling with. This basic math, this basic idea of getting these decimals, by the way. All right, and then it's y minus 4. Wait, whoa, wrong. Y minus 2.5. I looked at this, which is the focus. I should be looking at that. Not squared. Only one of them are squared. Then the last one we're going to do in a microsecond. Well, not really. Time is relative, though. I don't need to graph it. I'm just using the picture to know that it went up and to find those distances that are the key. That's it. A student just elected himself. I just found somebody sleeping. And I got to save their education because that's the kind of guy I am. It's not allowed. I call a student by the wrong name. I know it's December. By March, I'll know everybody. Okay. What's the answer? And I'll turn it off and see when we'll wait till you get it. Okay, we got that student activated here. Equals, opens left, positive or negative? Huh? Negative. Then what do you think the number is that goes in front? Huh? No. Everyone? It's 10. This is supposed to be 4p in this position. Focal width is defined as the absolute value of 4p. That is the number. That's why this is, you don't have to graph this one. All the information is given. By the way, how does it end? You didn't finish? And it is not what, everybody? Squared. There's only one squared in this. Okay, good. We got him. Hopefully he feels alive. Okay, take a minute to write that down. All right, first student in group 5. Okay, yes, we are going to complete the square. So you don't need knowledge of the thing that you didn't look at yesterday from, blah, 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 blah. Okay, how many things are squared in a parabola? Just say that. How many things are squared? Is both x and y squared? Yes or no? Just one of them. So if just one of them are squared, I only have to complete the square on one of those things. So with that being said, what you should do is get rid of everything else to the other side. So tell me, what would that look like? What would go on the other side? Not negative 6x. I have negative 6x over here, and I got to shift it over to that side. So what would it be? It'd be 6x and subtract 13. And I should not have to teach that. Whatever you do to one side. Your head's bobbing. You want to go next? Okay. And then plus blank. Next student in that group. What is the blank? So I want you to complete the square. No one say a word. I got to test if we know. 1, whatever you do to one side, you do to the other. Next student, factor. What does this become? Hopefully you're not just a robot. You understand what multiplies the 1 and adds the 2. And that turns into this factorization. We've done this a million times. What? Equals, you know what? We're going to do two things at once. This is negative 12, and now I'm going to get it in standard form, which means what should I do with the 6? Divide it out, or actually, what's the better word? Factor. What does that minus 12 become when I factor out and then you're done? Minus 2. Okay, now, this is how you can graph this real fast. What's the vertex? 2, negative 1. Don't do the old 1 or negative 1 comma 2. It's x comma y. X is with x, y is with y. By the way, we should be fast at this after, what's p equal to? Come on. It's just a decimal. 3 halves. Who said that? I think most of us will appreciate 1.5 though, right? 4 times 1.5 is 6, or how you find this is 4p equals 6. So I'm going to find this stuff. It's actually not hard. Everybody, which way does this go? Up, down, right, or left? It is right, and this is how you do this. Just do it. Blah, blah, blah. So you just draw it real quick. You don't need a coordinate plane at all. And you just need to know that this is 2, negative 1. Where do I have to go for the focus? Which direction? To the right. What is that mathematically? Who gets affected, the x or the y coordinate? To move right means the which coordinate? I got someone giving me X-Men symbols in the back. X. So I move right 1.5. The simple math is negative 3.5 comma negative 1. Which way do I have to move for the directrix? To the left. What is that kind of a line? Vertical. What is the x equals? What's the number when I move left 1.5 from 2? It's just 0.5 or a half if you wanted to make that a. This is not rocket science. This is what I mean about graphing. You graph a real quick sketch to just see what they are mathematically, what your math is to move. This is simple. And I'll leave you alone on this last one because of time. So again, I see this one. I'll give you a second to write it down. Hey, as you're writing this down, I should make a note. We're going to complete the square when we get all of them together. And a parabola sticks out like a sore thumb. You should know that's a parabola immediately comparative to all the other ones. Because ellipses have 2 squareds. Circles have 2 squareds. And hyperbolas will have x and y squared. Both of them 2. So you should know this is a parabola immediately. And you should do what that last group did immediately. Only y is squared. Anything that is not a y goes to the other side through valid math. Add x, subtract 1. This is another common error. Usually the mistakes people make are basic. They're not cat. I hate cat. It's too hard. Well, stop making mistakes that are not cat mistakes. It's your basic algebra skills. And no, you cannot take half of 16, which is 8, and square it and put 64 here. Invalid. Anyone know why? Because you have a what in front of that y squared? A negative 2. So you need to factor out that negative 2 like you did with ellipses. By the way, what does that 16 become? Negative 8. And now you can put your blank in. Whatever you do to one side. Just talking to Mr. Stanowski about a couple things. The lack of responsibility for absences. But also, they're doing this right now on Math 2 Honors. They're doing this, completing a square. And the biggest mistake he sees students doing is that grade school mistake. Whatever you do to one side, you do to the other. They're not even putting the blank on the other side. And I got the same thing, brother. Same thing in my CAT classes. Anyway, what's the blank on the left? What's this become? 16. Everyone should know this, and if you feel like, oh, where did he get that 16 from? You're severely what? Behind. It's half of negative 8, which is negative 4. Negative 4 squared, 16. This is not 16 over here. It's negative 32, because it's negative 2 times 16 that you actually added to the left side, so you must balance that. Couple things left. This is y minus 4, right? Negative 4 times negative 4, negative 4 plus negative 4. Then this equals a weird number, x minus 33. Is that in standard form? What do I got to do about that negative 2? Not divided, something better. Multiply by negative a half. And I am still going to graph this, and you're going to faint. I'm going to do it real fast because of our time. I'm going to multiply both sides by negative a half because it's better. Because it puts this in the correct form that I like to see. And then let's see those that are ahead of the class here. What's P then before I continue? Someone last hour got it like that. What's P? Oh, but you didn't say negative. And a stickler math teacher would get you. You darn right. 4P equals negative a half. I'd have to multiply both sides by 1/4 to find out what P is. Then guess what? Hey, which way does this go? Right, left, up, or down? I'm not even drawing a coordinate plane. Right, left, up, or down? It goes left. So all I have to do is find the vertex, which is 33 comma 4 is correct. And then which way do I have to move for the focus? Which way? To get in the bowl, I'd have to move what? I'd have to move what? Left. How far? How far? 1/8. Now I'm gonna be mad at someone that thinks this is calculus when I write this next number. 32 and nobody said it. 7/8. That's moving 1/8 left from 33. That is not rocket science. And then moving 1/8 to the right. What kind of line is that, by the way? Vertical. And if I move right an eighth from 33, what do I got? 33 and an eighth. Not rocket science. Okay, cereal bowl table makes this real easy. And that's all she wrote. Or he, or whatever.